Rohini College of Engineering and Technology from Department of Civil Engineering. So this is our civil engineering subject, final year 7th semester. So subject is CE 8703 Structural Design and Drawing. I am Michael Devadurai, Assistant Professor. So now we can see about the design for counterfeit retaining wall. So design for counterfeit retaining wall. So example, so design a counterfeit retaining wall based on the following data. So given data is height of wall above the ground level is 6 meter. Then SBC of soil. So SBC is nothing but safe bearing capacity of soil. So 160 kilonewton per meter square. Then angle of internal friction pi is equal to 33 degree. Then density of soil is equal to 16 kilonewton per meter cube. Then spacing of counterfeit is equal to 3 meter center to center distance, because this is our counterfeit wall. So this walls connecting from heel slab and vertical stem portions. Okay, then adopt M20 grade concrete and Fe415 HYSD bars. So step number 1, dimensions of retaining wall. So already we know that depth of foundation formula is P by W 1 minus sin pi divided by 1 plus sin pi the whole square. So P is given, safe bearing of capacity 160, then W is the unit weight of soil, so 16, then pi value is 33 degree, though apply the pi value is 1 by 3, so the whole square you got, final answer is 1.11 meter. So we can round it at depth of foundation is equal to 1.2 meter. Then overall height of wall, h is equal to 6 plus 1.2. So 6 is above the ground level, the 1.2 is below the ground level, so h is equal to 7.2 meter. Then thickness of a base slab is equal to 2 LH. Okay, so 2 is constant, though L is the spacing of counterfeit retaining wall. So our spacing is given in our question 3 meter. Then h is the 7.2 overall height of wall. So thickness of base slab is 43.2 centimeter. So we convert to mm, 432 mm, or meter 4.32 meter. Then we can provide a 450 mm thick base slab. Okay, so base width is equal to, we can on condition 0.6 h to 0.7 h. So h is known value, so 0.6 into 7.2, we got it 4.32 meter, or 0.7 into 7.20, 5.04. We can approximately take as adopt base width is equal to 4.5 meter. Then toe projection. So toe projection means the cantilever projection, toe slab projections. So 1 by 4 into 4.5. So our length is 1.1 meter. So step number 2, design of stem. So pressure intensity at base is equal to WH into 1 minus sin pi divided by 1 plus sin pi. This is a basic formula. So h is equal to 7.2 minus 0.45. This is our finding on the stem height. So overall depth minus thickness of base slab. So this is the 7.2 minus 0.45. So our answer is 6.75 meter. Then pressure intensity. So 16 into 6.75 into 1 by 3 is equal to 36 kilonewton per meter square. So our maximum working moment is, so W L square by 12. So W is the 36 into L is the spacing of our counterfeit retaining wall, 3 square. So divided by 12, we got our answer is 27 kilonewton meter. So our factor moment is simple. So moment into factor load. So factor load is 1.5 is constant, we know that. So 27 into 1.5 is equal to 40.5 kilonewton meter. Then effective depth required for balanced section is in a simple formula, d is equal to square root of mu divided by 0.138 FCK into B. So mu is factored moment, so 0.138 is constant. Then FCK is given in our question, so B is 1000 mm. For all cantilever problems we are taken as a 1000 mm or 1 meter. So D is equal to 121 mm. So adopt a overall thickness of 220 mm constant up to top. So see the diagram. So mark the values. So this is our counterfeit retaining wall. So base slab we can split into, one is the toe slab, the another one is the heel slab. So the vertical position is stem position. So this trapezoidal shape is, this is cross section for our retaining wall. So we can see the trapezoidal shape. That shape is we called as a counterfeit wall. Okay, so their height is the 6.75 meter, so top width is 0.2 meter. So effective depth d is equal to 175 mm. Then the reinforcement in the stem are computed using the relations. So mu is equal to 0.87 Fy AST into T, 1 minus AST Fy BD into FCK. So this formula is taken from our code book IS 456 2000 from page number 96. So class number 1.1. So we know that moment value 40.6 into 10 power 6. So 0.87 is constant value. Then FO is given in our question. So FE 4 and 5. Then AST is constant, because in this step we need to find out the AST values. So D is equal to 175 mm. So 1 minus AST is constant. So FO is 4 and 5. Then B is equal to 1000 mm. So D is equal to 175 mm. So FCK is equal to 20 Newton per mm square. That FCK is given in our question. So finally we got AST is equal to 700 mm square. So next you find out the spacing. So provide 12 mm dia bars at 150 mm center to center spacing. Then minimum reinforcement is 0.12% of cross section of area. So 0.12 divided by 100 into B into D. So 0.12 into 220 into 100. So is equal to 264 mm square per meter. So next we can find the spacing value, same as the minimum reinforcement. Adopt 6 mm dia bars at 220 mm center to center distance. So step number 3, stability calculation. So first one, find load. W1 is equal to B into D into gamma C. B is a known value 0.22 and D is the height of the stem 6.75 and gamma C is the unit weight of concrete 24. Then W1 is equal to 35.64 kilonewton. Then W2 is equal to B into D into gamma C. This is a rectangular shape position, so we can use the rectangular area formula. So B is equal to 0.45, so thickness of base slab. So now our width of slab is 4.5 meter. Then gamma C is unit weight of concrete, we taken as 24. So W2 is equal to 48.60 kilonewton. Then W3, so W3 is B into D into gamma S, because W3 is the soil position. Okay, we already studied in our cantilever retaining wall what is W1, what is W2 and what is W3. So B is equal to 3.28 into 6.75 into 16. 16 is our unit weight of soil, so that is, it will be given in our question. So total W1 plus W2 plus W3. So total load is equal to 438.49 kilonewton. So find moment. So m1, m2, m3. So simple formula, we know that moment is equal to load into distance. We know the W1, W2, W3 values, and the length also we know that. So simple, load into distance. Apply all the values and load and distance. You got m1, m2 and m3 values. Then m4 is the moment of earth pressure. So we can separate formula. K is equal to WH cube by 6. So K is equal to 1 by 3 and W is equal to 16 and H cube 7.2. H is the stem, height of the stem. Then M4 is equal to 331.77 kilonewton meter. So that will be called as a moment at base moment. So total moment is equal to M is equal to M1 plus M2 plus M3 plus M4. So add all the moment values. So our answer is 1142.87 kilonewton meter. Then distance of the point of application of the resultant from point A is Z is equal to sum of moment by sum of load. We know that sum of moment, also we know that sum of load. So sum of moment is equal to 1142.87 and sum of load is equal to 438.49. So Z is equal to 2.66 meter. So eccentricity formula Z minus B by 2. So Z is 2.66 and B is equal to 4.5 meter. So this 4.5 meter from width of the base slab. So E is equal to 0.441 meter. So we have one condition, E is less than B by 6. So B by 6, 4.5 divided by 6 is a 0.75. So this condition is safe. Then minimum and maximum pressure at the base are given by is a simple formula. Sigma max is equal to sum of load by B, then bracket 1 plus or minus 6C by B. Sometimes it will be sigma max, you can take it as a 1 plus, or otherwise you sigma minimum, you taken as a 1 minus. So sum of load is 438.49, so B is equal to 4.5. So 6 into E is equal to 0.41 divided by B is equal to 4.5. So sigma maximum is equal to 150 kilonewton per meter square. So sigma minimum is equal to 1 minus that answer. So you got to the 45 kilonewton per meter square. The maximum intensity of pressure does not exceed the permissible value of 160 Newton per mm square. The next step number 4, design of counterfeit. So thickness provided top, so 220 plus 220 is equal to 440 mm. So thickness of counterfeit is equal to 440 mm. So maximum working moment is counterfeit is, so we know that moment formula m is equal to Ka into W h cube by 6 into L. So we know all the values, so apply that directly, you got the moment values. Then factor the moment, so factor moment is nothing but that moment multiplied by load, factor load. The factor load is 1.5, so our moment is 820, so multiplied by 1230 kilonewton meter. Then reinforcements at the top of a counterfeit is computed using these relations. So you find out the AST values. So this AST formula is taken from our codebook IS 456 2000 page number 96. Sorry, AST is equal to 800 mm square. But minimum reinforcement is ISF code by AST is equal to 0.85 BD divided by Fy. So B is the 440, D is the 444 divided by 415. 415 is the Fy is given in our question. So AST is equal to 3965 mm square. So provide 5 bars of 32 mm diabars. So this is, we can provide that. Okay, so you can 5 bars or 6 bars or 32 mm or 25 mm you can take. So AS is equal to 4020 mm square. Then step number 5, curtailment of bars. So curtailment is 1 meter above or top the values. Okay, so H1 is equal to depth at which one bar can be curtailed. Then so 5 minus 1 divided by 5, so H1 divided by 6.75 is the stem height of the stem whole square. The H1 is equal to 6 meter from the top. So H2 is equal to depth at 2 bars are curtailed. So H1 is the 1 bar and H2 is the 2 bars. So 5 minus 2, our H2 is equal to 5.2 meter from top. So H3 is 3 bar curtailed. So 5 minus 3. Then our H3 is 4.2 meter from top. So remaining 2 bars are taken right up to the top. So connection between counterfeit and upright slab. Okay, so considering bottom 1 meter height up to right slab, so pressure on this strip 36 kilonewton per meter square. Then total working load pressure transferred to the counterfeit for 1 meter is equal to 36 into 3 minus 0.44. So this values are 91.8 kilonewton. Our factor to 40 is simple, 91.8 into our factor load is 1.5, so multiply the values, so you got the answer is 138 kilonewton. Then reinforcement required per meter, so you need to multiply cross sections. So 138 into 10 power 3 divided by 0.87 into Fy. Fy is given in our question, so directly apply the 415. So 382 mm square. Then minimum reinforcement is equal to 0.12 percentage of cross section of area. So apply the cross sections and 0.12 percentage values. Then 528 mm square. Then provide 10 mm diabars we can provide. So finding out the spacings is equal to 78.5 into 1000 divided by 52.8 is the AST. So 528. So spacing is 148.6 mm. So with the rounders, the reinforcement is provided as two legged horizontal lines of 10 mm diabars at 280 mm center to center distance. So step number 7, connection between counterfeit and heel slab. So working transferred 1 meter width of counterfeit near heel slab end. So A is equal to 73.80 into 3 minus 0.45 thickness of slab. So got the A is equal to 189 kilonewton. Our factor tension is simple. So 189 into multiplied by the factor load. Our factor load is 1.5. So our answer is factor tension is equal to 283.5 kilonewton. So reinforcement required in 1 meter width. So reinforcement form is known moment divided by 0.87 into Fy. So factor tension is 283.5 into 10 power 3. So that will be kilonewton converted into Newton. So into 10 power 3, then 0.87 is constant and Fy is the given in our question. So Fy is the 4 and 5. So reinforcement is 785 mm square. Then provide 10 mm diameter 2 legged stirrups. Then is equal to 2 into 78.5 into 10 power 3 divided by 785 is the reinforcement area. Then you got a spacing is 200 mm. So provides 10 mm diameter 2 legged links at 200 mm center to center distance. Thank you.